This is Pre-Calculus 12, Chapter 8.4. This time we're going to be looking at combinations, and combinations are used when order does not matter. And we have this notation: n choose r equals n factorial over n minus r factorial times r factorial. Another way to write this is with parentheses, n over r. And there's some nice properties. So n choose 0 is always 1. N choose n is always 1. N choose 1 is always n, and n choose n minus 1 is always n. And you want to note that this is similar to the treatment of identical objects in an arrangement. Wendy's has 8 items on their value menu. How many ways are there to order 3 items? And we want unique items, not repeating items. So ask yourself, does it matter if we order a Frosty, junior bacon, cheeseburger, and fries in that order, or ordering fries, junior bacon, cheeseburger, and a Frosty? No. You can eat them any way you want after you order it. So this is a combination problem. Not a permutation. Since the order doesn't matter. For the 3 items. And we can divide by 3 factorial ways. Okay, so that's why it's similar to the identical objects in an arrangement. So the answer is 8 choose 3. That's 8 factorial over 8 minus 3 factorial times 3 factorial. This is not hard to do. We have 8 times 7 times 6 over 3 factorial, which is 6. So we have 56 ways. However, we can use our calculator to do this too. And we go 8, and we go math, and probability, and number 3 is the combination, and we enter 3, and we got 56. And on the Casio, menu 1, 8, option, F6, F3 for probability, F3 for combination, and 3. And we get 56. Okay, so the more of these problems you interpret, the easier it gets to do them on a test. 10 students are running for student council. 6 will get elected. How many ways can the council be formed? And again, you want to note that order doesn't matter. Doesn't matter who gets elected first. They're all sitting on the council. Doesn't matter if they're last. Still sitting on the council. So we have 10 students to choose from, and we're choosing 6. So 10 factorial over 10 minus 6 factorial and 6 factorial. So we can do this one, 10 times 9 times 8 times 7. The 6 factorial cancels out here, and it's over 4 factorial. So that's 4 times 3 times 2 times 1. We don't need to put the times 1, but I'll just put it in there anyways. And we can cancel 4 times 2 is 8. We can cancel a 3 from there. So 7 times 3 is 21, and times 10 is 210. Again, you can use your calculator if you like, but lots of things cancel out. So you must be able to determine whether to use permutations or combinations because you won't always be told. Sometimes it might say combinations, but it means permutations. Sometimes it's talking about an arrangement, but it means combinations. And unfortunately, with combinatorics, it's easy to get an answer. However, you won't know if your answer is right or not unless you are very careful with checking the wording. And that's why we say counting is hard. Okay, so there's symmetry for combinations. It doesn't happen for permutations. So if we look at 7 choose 4, that's the same as 7 choose 3. We look at 6 choose 2, that's the same as 6 choose 4. 9 choose 3 is the same as 9 choose 6. And let's do a proof. And what we're trying to prove is n choose r equals n choose n minus r. So left-hand side, n choose r. This is n factorial over n minus r factorial times r factorial. And now we want to rearrange the denominator, r factorial times n minus r factorial. And we want to do some rearranging again. N minus n minus r is the same as r factorial. And we have n minus r factorial. So what we're doing here is we're letting r equals n minus r. If we expand this, we get n minus n, and we get plus r, and that's just r. So now that we've rearranged it into the first form, we have n choose n minus r. And then we substitute n minus r into here instead of r. So this equals the right-hand side, QED. Okay, given that Lotto 649 has odds of 49 choose 6, this is approximately 14 million to 1 of winning the jackpot. What are the odds of winning Lotto 4349, where you pick 43 numbers? Now, it doesn't look like the odds are going to be the same, but we know better. 49 choose 43 equals same number, 13,983,816, using the property that we just proved. So 49 choose 6 equals 49 choose 43. And because we already calculated it, we don't need to calculate it again. We just use the property. If there are multiple combinations, then we use the fundamental counting principle and multiply the answers together. So we're doing arrangements of combinations. So an ice cream store has 10 flavors of ice cream and 21 mix-in flavors. How many flavors can you get if you're allowed 2 ice cream choices and 2 mix-in choices? 10 choose 2 times 21 choose 2. That gives us 9450 unique flavors. And as you've seen, we've done backwards problems. And you're going to say, oh, Mr. Wong, are we going to have to do backwards problems for combinations? And the answer is yes. Find n or r. Okay, n choose 2 equals 36. So we have n factorial over n minus 2 factorial times 2 factorial equals 36. So we can simplify this side, n times n minus 1, because we know n minus 2 factorial will cancel out. 36 times 2 is 72. We need two consecutive numbers. That multiply to 72. Okay, if for some reason you forget your multiplication tables, you can take a guess. 7 plus 2 is 9, so that means it's divisible by 9. So n equals 9. So 9 times 8 gives you 72. We know it has to be 9 times 10 or 9 times 8 once we found one factor. Clearly 9 times 10 is not going to give you 72. Okay, the other option is to do some algebra with that expression. But it's not hard to reason it out. Okay, 10 choose R equals 120. Unfortunately, this way is really guess and test. But you can try to make some argument. Rather than guessing and testing, what I like to do is look at this pattern. 10 choose 1 is 10 factorial over 9 factorial times 1 factorial. But what does this mean? This means 10. 10 choose 2. We're going to start to see a pattern developing here. This time we have 10 times 9 divided by 2. And that's 45. 10 choose 3 equals 10 factorial divided by 7 factorial times 3 factorial. So this is 10 times 9 times 8 divided by 3 times 2. So we look at what we're adding each time. We've added a 9, we've added a 2, we've added an 8, we've added a 3. This equals 120. It's the correct answer. So on a calculator, all we have to do is start with our starting number, 10. That's not it. So we multiply by 1 below, and we start counting from 1 divided by 2. That's not it, so we multiply by 8 and divide by 3. If we had to go further, if 120 wasn't the answer, we'd multiply by 7 and divide by 4. And then the next one would be 210. So I think this is faster than trying to do 10 choose 1, 10 choose 2, 10 choose 3. So think about what situation applies. Does arrangement matter? If not, then it's like a combination problem. Then it's likely a combination problem. And that completes this lesson.